This is Lab 3 Black Hole for Physics 1 at Georgia Tech. So the purpose of this lab is to explore the orbit of a star around a black hole in part 1, and then to determine the velocity that a spaceship can fly around both a planet and the black hole without crashing in part 2. And I used Python and GlowScript to create models and generate the data in this lab. And the biggest limitation in the lab was the trial and error method, which will come up later. So before we get into the actual coding, it's important to talk about some of the fundamental concepts that play into this lab. It starts with Newton's second law, which is that the net force is equal to change in momentum over change in time. And you can derive the velocity and position update formulas from Newton's second law, which are listed, as well as breaking down the vectors into their scalars and magnitudes. And it's also important to know the formula for the gravitational force and the universal gravitation constant, which is listed. And then another big concept is that net force and momentum can be broken down into their parallel and perpendicular components. So net force is equal to parallel net force plus perpendicular net force, as well as the parallel component of the rate of change of momentum plus the perpendicular component of the rate and change of momentum, which are broken down into their respective formulas at the bottom. So for the code in part 1, I entered my email and then the mass of the star, which was given in the instructions, and then the number of seconds in a day. And then in the while loop for part 1, I used the momentum principle. Momentum equals mass times velocity, and then I used final minus initial to calculate the change in velocity and momentum. Using these values, I found dp dt, which is equal to net force, and then I found p hat by dividing the initial momentum by its magnitude, and the parallel component of net force was equal to the parallel component of momentum. The same applied to the perpendicular components, and then I calculated the gravitational force using the formula for gravity. And lastly, I updated the arrow formulas to reflect the above changes. And so after running the code, this is the graph that was generated, and I used the printed iterative mass values to calculate the average mass for the black hole in an Excel spreadsheet. And the code also printed the net force and its components for the spaceship, and in the video, Fnet is shown by the orange arrow, the parallel component of Fnet is shown by the magenta arrow, and then the perpendicular component of net force is shown by the blue arrow. And then in part 2 of the code, I updated the mass of the black hole given what was calculated in part 1, and then I did 2 iterations of writing formulas for gravitational force. First for the black hole on the planet, and then the ship on the planet, and then second for the black hole on the ship and the planet on the ship, and then these netted to give the net force on the planet and the ship respectively. And then finally, I used the velocity and position update formulas for both the planet and the ship. In the last section of code, I used trial and error to find the x and y components of velocity that get the ship closest to the planet and black hole without crashing, and I found that negative 3.67 to the 10 times 10 to the 7th 1.5 times 10 to the 6 was the closest that I could get for velocity. And as you can see in the video that was produced by the code, you can see that the ship trajectory in magenta narrowly misses the black hole while the planet in blue continues to orbit. So the what does it mean question asks how the net force and the rate of change of momentum are different, and technically they're equal because of Newton's second law, but they represent different things. Momentum is its components are the propensity of an object in motion to continue moving, while net force is the force applied to make the object move in the first place. And then the what if question asks what initial velocity would the spaceship need to have to orbit the black hole? And to do this, I once again used trial and error and found that the velocity negative 2 times 10 to the 6th, 0.8 times 10 to the 7th, allowed the ship to enter orbit around the black hole alongside the planet.